In the vast, silent reaches of space, where darkness seems endless, great clouds of gas and dust drift for millions of years. These are nebulae, cosmic nurseries where the seeds of creation lie hidden. Within these swirling clouds, gravity begins its quiet, patient work. Atoms of hydrogen, drawn together by an invisible force, cluster more and more tightly. Pressure builds. Temperatures rise. For thousands, then millions of years, the cloud collapses in on itself. And then, a spark. Nuclear fusion ignites. A star is born, not in silence, but in a burst of radiant energy. For the first time, the darkness is pierced by light. This newborn star, fragile yet powerful, announces its existence to the universe. It is the beginning of a journey that may last billions of years. The Orion Nebula, visible through even modest telescopes from Earth, is one such cradle of stars. There, new suns are forming even now, reminders that creation is still unfolding, not in some distant past, but here, in this very moment of cosmic time.
A young star grows stronger with each passing million years. It enters what astronomers call the main sequence, the longest and most stable period of its life. Here, hydrogen atoms fuse to form helium, releasing unimaginable amounts of energy. This energy radiates outward as heat and light, balancing the crushing inward pull of gravity. The result is a delicate equilibrium, a fiery heartbeat that can last for billions of years. Our own sun is in this stage now, about halfway through its life. For 4.6 billion years, it has burned steadily, warming the Earth, nurturing life, and holding the planets in orbit. It is a modest star, neither giant nor dwarf, yet to us it is everything. Imagine countless stars across the Milky Way, each a miniature sun, each with its own potential worlds, perhaps even its own stories of life. They may seem like distant points of light in our night sky, but each is a blazing sphere of fire, as real and alive as our own sun. Not all stars are alike. Some are massive, tens or even hundreds of times larger than our sun. These stars burn hotter, brighter, and faster, living only a few million years before meeting a violent end. Others are smaller, glowing faintly as red dwarfs, slowly burning their fuel for trillions of years, outliving nearly everything else in the cosmos. Then there are the exotic stars, neutron stars, so dense that a single teaspoon of their matter would weigh as much as a mountain. Pulsars spinning rapidly, flashing beams of light across the galaxy like cosmic lighthouses. And of course, the white dwarfs, the fading embers of once splendid suns. Each type of star plays a role in the grand cosmic symphony. Some create the heavy elements necessary for planets and life. Others provide the steady warmth that may nurture living worlds. And together they shape the tapestry of galaxies, the architecture of the universe itself. Even the mightiest stars cannot live forever. As they exhaust their fuel, their delicate balance between gravity and energy begins to fail. For stars like our sun, the end will come quietly. It will swell into a red giant, expanding far beyond its current size, perhaps even engulfing the inner planets. Then, shedding its outer layers, it will shrink into a white dwarf, glowing faintly as it slowly cools into darkness. But for massive stars, the end is far more violent. When their fuel is spent, gravity wins. The core collapses in an instant, triggering a titanic explosion known as a supernova. For a brief moment, the dying star outshines entire galaxies, releasing more energy than our sun will produce in its entire lifetime. These explosions scatter elements across space: carbon, oxygen, iron, gold. From this debris, new stars and planets are born. In this way, every death becomes a new beginning. The universe is a cycle of destruction and rebirth, written in the lives of stars. For the most massive stars, death does not end in light, but in darkness. Their collapse is so complete that nothing, no matter, no radiation, not even light, can escape their gravity. Thus, a black hole is born. Around a black hole, space itself bends. Time stretches. What falls inside disappears forever beyond the event horizon. Black holes are not monsters. They are the silent remnants of once great stars, reshaping the fabric of reality itself. At the center of many galaxies, including our own Milky Way, lie supermassive black holes. Millions of times heavier than the sun, their influence reaches across thousands of light years, shaping the orbits of stars and the destiny of galaxies. They are the universe's greatest mysteries, dark, hidden, and awe-inspiring. When we look at the night sky, we are not just seeing stars. We are seeing our own origins, the iron in our blood, the oxygen we breathe, the calcium in our bones, All of it was forged in the heart of a star that lived and died long before our sun was born. We are stardust. Every living thing on Earth carries within it the ashes of ancient suns. To gaze at the stars is to look back in time, to recognize the shared history between the cosmos and ourselves. And so, the life of a star is not just the story of distant suns. It is our story, the story of how the universe became aware of itself through us, its children. As stars are born, live, and die, the universe dances an eternal rhythm. And as long as we look to the sky, we remain a part of that dance.